Hello, everybody. Welcome to our virtual field trip today. My name is Jacqueline Durakis, and I am the Expedition Manager for EarthEcho International. We're excited to have classrooms from all over the globe joining us today as we learn about white sharks and the health of our oceans. This live event is a teaser for our 2018 expedition, Plastic Seas. Our expedition this year will be happening in Australia. In October, our team, along with teachers from Melbourne, Australia, will be looking at ocean plastic pollution. Before we get started today, I'd like to go over a little bit of housekeeping for everybody who's watching. We love participation. So you can ask questions using the YouTube Q&A app, which is, if you're watching on YouTube, right below the video. And if you're watching on earthecho.org, you can use the Google form that's equally right below the viewer and ask us questions. So make sure you get those questions in, and we will try to answer them as we go through the event today. Any questions we don't get to, I will make sure we answer and send you an email with those responses. So today we have two classrooms joining us. We have Mrs. Martinez's class from Harlow Elementary. And we also, there she is. Hi, Mrs. Martinez. And we also have Mrs. Trumper's class from Bednarsik Middle School, and they are both in California. So thank you guys for joining us today. Both of these educators are EarthEcho Fellows. So they went on expedition with us last year, and we have the ability to have their classrooms on live with us today. Our special guest and host for today's live event is Mrs. Lindsay Lauper, who is the OCEARCH Education Ambassador. She's coming to us live from Maryland. So go ahead and take it away, Lindsay. Thank you.
Thank you so much. Good morning. How is everybody this morning? It's good to be here with you. Yes, my name is Lindsay Lauper, and as you said, and I'm an education ambassador with OCEARCH. I've been with OCEARCH now for about 3 years. And I've been on 6 different expeditions with them. I'm about to join them up for a 7th at the end when we do education outreach at the end of this expedition that's going on currently. We'll talk about that in a little bit. And I do 2 things as part of my role on the education team as a volunteer. The first thing that I get to do is to help out with curriculum. So if you wouldn't mind we can go ahead. There we go. So I helped develop the OCEARCH STEM curriculum in collaboration with Landry's, especially that kindergarten through 8th grade component. And when doing the OCEARCH STEM curriculum, we have it linked to the next generation science standards. So you can be learning science, technology, engineering, and math while you're tracking your favorite sharks and learning all about the ocean, which has been so much fun working with them on that. And then also a couple years ago, we started doing expedition packets. So whenever OCEARCH goes on expedition, you can look for an expedition STEM activity packet. And that packet is linked to all the research that's going on that expedition with that science and with those scientists. So when OCEARCH goes on expedition, you can watch their Shark Science Friday videos and learn about the curriculum that way and learn about the science that way. And you can watch them tagging sharks live when they're able to on Periscope and learning the lessons behind all of it and tie it all together with the science and the education. So that has been a whole lot of fun. All of that is free and open sourced and available on our website at ocearch.org under the Education tab. And then the second part of what I do in my role for OCEARCH is helping with outreach. And that looks like programs and being able to go into different communities when we're on and off expedition. So when I'm not on expedition helping with community outreach, I'm doing wonderful things like this with all of you, doing Skype sessions and virtual field trips and going to conferences and talking to teachers and educators there. And then when we're on expedition, OCEARCH brings the community to the ship when they're docked. And when we're docked, we can have things like STEM camps that we've helped put together. All the programs are free. We've done teacher workshops, so teachers can come to the vessel and hear about the curriculum and use it in our activities and be a part of meeting the crew and meeting the scientists as well. And we also will then go into the schools in that area where they're on expedition as well and do presentations and really connect the community to the ship and also to the ocean and the science that's going on right next to them. So that is a bit about what I do with them. And I'm so excited to be talking to you today about OCEARCH and the Atlantic white shark puzzle. But the best person to tell you about OCEARCH would be Chris Fisher, our founder. And so we'll go ahead and you can
Lindsay, before we go to the video real quick, we have a question from Tom Rivers School STEAM Academy, and they want to know, how do you go about joining the OCEARCH team?
So what is great about OCEARCH is it's a huge collaboration. We have researchers and scientists that come on board the vessel. We have underwater photographers like Rob Snow, who comes to the vessel and helps out with photography. We have a chef, we have ship engineers, we have an expert fishing crew. And so there are many ways to be involved in different career paths to be a part of OCEARCH. But you are a part of OCEARCH by looking at the research and engaging with us on social media and helping to replace fear with facts with people and educating them about the ocean and sharks and how important they are. And so, but those are some of the different fields that we have on the ship.
Great, thank you. All right. We'll go to the video.
So really, when you think about sharks, they are the indicator species, the sentinel species, and if they struggle, we will not have a healthy, robust planet. OCEARCH is a data-centric organization. It's an enterprise we built to help scientists collect previously unobtainable data in the ocean to help move the system toward abundance. What we're simply trying to do is learn what's never been learned before at a rate that's never been achieved. And the only way to do that is to enable big collaborative teams. That's why we have many different scientists from many different institutions, all with different disciplines, maximizing the leap forward in knowledge on every single animal we touch. And integrated into a STEM educational curriculum, and then in a long term, the children are being educated in a data-driven, centrist way to be the practical planet and resource guardians of the future. It's about total inclusion at every level. Exploration in the now, science in the now, education in the now.
So yeah, OCEARCH was started in 2007 by Chris Fisher. And in 2013, OCEARCH went on expedition to Cape Cod. They received a call from a scientist over there who said, we really need to know about our North Atlantic white sharks. We don't know where they're going, their movements in the North Atlantic. We don't know where they're giving birth and where they're mating. And all of these are very important pieces of a puzzle that we have, which has become the puzzle of the North Atlantic white shark. But you might think, why white sharks? Why do we need to know about the North Atlantic white shark? Well, that is 200,000 sharks die every day for things like shark fin soup, trophies, liver oil, and for their skin. And that's not sustainable for a healthy future for our sharks, nor is it a healthy, sustainable future for the ocean. As you may have heard in the video, Mr. Fisher talks about how white sharks are apex predators and a keystone species. So actually, I'm going to turn this over to you, Mrs. Trumper's class. Do you know what the difference is between an apex predator and a keystone species?
Don't be shy, guys. Anyone have a guess? Feel free to guess. I think we're being shy today.
I love seeing them think, though. This is great. So an apex predator is going to be at the top of the marine food chain, right? They're going to be keeping the balance of that food chain that they're in. So, but a keystone species can also be an apex predator. A keystone species is going to be one of your top tier predators. But if they are removed from that tier in its environment, in this case, it'd be if you took the white sharks out of the ocean, then it affects the entire health of the ocean. So if we were to lose our white sharks, the entire health of the North Atlantic would be in jeopardy, would be in trouble. And so as Chris Fisher says, if we lose our sharks, we would lose our ocean. And so it's important to know where they are and how they reproduce and where they go, because we didn't know those pieces starting in 2013. And one of the things about white sharks in particular is this species is slow to mature. They become mature when they're 20 years old, and they only have 1 to 2 pups at a time. So their populations can't handle a whole lot of stress. It's important that we're able to manage them as mature animals, as immature animals, and as young of the years, as pups as well. So that's why the puzzle is so important and why this research needed to be done. So we can go ahead and I will tell you a little bit about all these different projects. So we have a wonderful expert fishing team that when they're on expedition goes out very early in the morning at like 5:30 or 6 o'clock in the morning. Are any of you up at that time? Yes, some of us are, some of us are not. Well, they're out fishing at that time. And so the fishermen go out and they go and have, at the head of the fishing team is Captain Brett McBride, who's our fishing master and our captain. And he is looking at the areas where the white sharks are. When they capture one, they use a hand line method, and they'll walk that shark behind the contender fishing boat. It's about a 30-foot fishing boat, and walk it around to, you can see the lift here, to a hydraulic lift that goes over to the side of the ship and drops into the water for about 3 feet, about chest high. And then the shark is brought onto the lift, and the lift comes out of the water, and we start a timer. And we're able to do 12 research projects on that shark in 15 minutes before it's tagged and released. When the shark reaches the lift, it has a saltwater hose that's put in its mouth, or 2, depending on its size, and a towel goes over its eyes, and the timer starts. And we'll take measurements, and those measurements will help us tell us about its life stage and its health. And then we do a stress physiology test where a scientist will come on and take blood from the caudal vein, and it is time stamped. And then just like a NASCAR or IndyCar pit crew, these scientists come on board one at a time, performing their research projects, collecting samples like parasites and blood samples, fin clips, muscle plugs, doing an ultrasound, which you'll hear about in a little bit, and be able to do those in often less than 15 minutes. And then the last scientist to leave is also usually the stress physiology scientist, who comes on and does another blood draw and then comes off the lift. There are usually 3 tags put on the shark, and then it's tagged and released to go. That blood is then taken to a centrifuge, and there's a blood gas analysis that is performed, and we can tell how much stress the shark is under or isn't under in a lot of cases during the course of the time that it's on the lift. There are certain species of sharks that can't be under a lot of stress. But what's so great about this method that OCEARCH has developed is that we have been able to show that the stress levels in the shark actually go down while it's on the lift. So that's really great news, because we are always monitoring the health of the shark, making sure everybody's safe, including the shark, before it's tagged and released. But these are some of the 12 research projects. We have bite force and ultrasound, reproduction, bacteria. We have a scientist, Dr. Christine Bedore, who's studying shark vision as part of their senses. DNA and genetics, thermal physiology is really interesting. White sharks are endothermic, which makes them different than a lot of other fishes. A lot of fish have to rely on the ocean to regulate their body temperatures, but white sharks don't. They are endothermic. They're able to help regulate their own internal body temperatures. And when we were able to do the young of the year studies, which we'll talk about soon, those young of the year white sharks, we did a stress physiology to see how they're regulating their body temperature is related to mature white shark temperatures and what are the differences or similarities in then. So, but we mentioned the tags, which has been a huge part of all of these research projects, believe it or not. And it's been great to see how these individual projects are fitting in together, and these scientists are able to see how they fit into as part of that piece into that bigger puzzle. But the tags are also a really interesting piece of technology where we've been able to collect data from salinity and different things, and we'll talk about the tags in a minute. But the first research project I think you'll really like is from Dr. Kim Ritchie, and she's going to talk to you a bit on this video about shark bacteria and immune systems.
Sharks and rays have this amazing ability to heal their wounds very quickly. My part is to see if there's a beneficial microbial component. And from what we've seen in stingray research, there is. There are a high percentage of bacteria that may act as an immune system, that first line of defense for sharks and rays that produce antibiotics. We're running out of antibiotics that work worldwide. And this is a novel source of new antibiotics and another avenue of interest for some lines of research.
So it's exciting what the future holds for that particular project, because it's not only helping us understand how sharks heal, but it also can benefit people as well. So I'm really excited to hear more from her about her research in the future, because all these projects can take some time, and that's what's so great about bringing everybody together too, is we're maximizing the amount of data that we're collecting. So another piece of this puzzle is about white shark reproduction. Where are they mating? Where are they giving birth? And this is Clark Morgan, who will talk a bit about what Dr. Jim Gelschleider's lab is working on.
My name is Clark Morgan. I'm a graduate student at the University of North Florida. I'm representing our lab to study the reproductive biology and ecology of the animals we catch here on board OCEARCH. My job on board is to use this ultrasound machine to perform a sonograph on the white shark in order to understand if it's pregnant or not, so that we can better understand its reproductive biology and ecology. The idea behind the ultrasound machine is when we're on the lift, I'll put these goggles on, and then I'll use this probe to scan the side of the shark underneath the belly. And what I'm looking for is the presence of pups. We're trying to use that information to understand how these animals are using their environments, where they're moving, why they're going there, and hopefully to work towards creating a shark pregnancy test.
Yeah, so they're developing a shark pregnancy test, looking at hormone levels and using the ultrasound information to develop that. The ultrasound machine is really cool too, because it'll also tell you, like on Catherine, when they tagged Catherine, they could tell that she was about at the cusp of maturity, which means she was in between being an immature shark and a mature shark ready to be able to reproduce. And so to be able to do that, a scientist can go and do that ultrasound machine and look at her reproductive organs, and based on their size can help determine or confirm her life stage, which is really neat. And actually the size of these sharks are factored into that too when determining life stage, which is really cool. And looking for the presence of pups. And I believe there was a black-nosed shark that OCEARCH found and was able to do an ultrasound on, and they did find like 6 pups. and that black nose shark, and you can take a look at the video and see the sonogram and what that looked like, which is pretty cool.
Lindsay,
And so then, go ahead.
Before we move on to tags, we have a question from Michael. And his 5-year-old son wants to know, how fast do these sharks swim, and can they stop?
Oh, that's so interesting. Thank you so much for your question. So white sharks, I can tell you a little bit about. They can reach up to top speeds, like when they're about to breach, of about 25 miles per hour, but they're not going that fast all the time. They're usually just cruising along. And so white sharks are ram ventilators. So as they're swimming along, it's important that they don't stop. A ram ventilator, a shark, has to have that movement of the water going in through its mouth, past its internal gills and out its external gills, in order to be able to breathe. So that's actually what the saltwater hoses will help. So when the shark is brought onto the lift and isn't swimming, the saltwater hoses are pumping that water across the salt water across its internal gills and out its external gills, so it's able to be oxygenated and be able to breathe without any problem. And we have scientists, and Captain McBride is always monitoring the water flow through those gills while they're on the lift. That's a great question. Thanks so much.
Do we have time for just a couple more?
Sure.
They're all about the white shark. So how long can they live? How many offspring do they usually have? And what do they eat?
Oh, this is all so great. Okay, so how long do they live? White sharks can live to be about 70 years old, we think. Mary Lee is a 16-foot white shark, 3,500 pounds. And we think she was about 50 years old right now. And then they can give birth about every 2 to 3 years, and they'll give birth to 1 to 2 pups at a time. And they're eating different, those young of the year or pups, baby white sharks, are going to be eating different things than the adult and immature white sharks. So our young of the year white sharks, we're finding out, this is all information that's developing too, because we don't know a whole lot about these young of the years, which is really exciting to start to see that come together. But they're eating things like sea robins that are close to the bottom of the seafloor. They're eating things like sea stars. And immature sharks will also, or juvenile white sharks will also eat rays. So those are some of those pieces. Like I said, we're still learning about what exactly these young of the years are eating, but that's Dr. Lisa Hoops's research, and I look forward to hearing more about. She can tell, this is really cool, white sharks are what they eat. You can tell what a white shark has had for breakfast based on a blood sample. And then if you use some muscle tissue, you can see over a longer period of time what it's been eating. So if I think about what I am, what I eat, it helps me to really think about maybe what I'm eating a little bit more. And white sharks, we can tell what they're eating as well. But our mature animals, our Mary Lees and our Hiltons and our George on the tracker, they're going to be eating things like seals, or they'll take advantage of like dead whale carcasses, dolphins, other smaller shark species. There are studies being done to see whether they're eating like black tip sharks that are migrating through Florida. And so we're also still looking at the range. They'll even eat big sport fish like rockfish or redfish and things like that. So whatever is easy for a white shark to eat, where it's not going to expend a lot of energy, is my understanding, is more like what they're going to eat. So, but that's what's on the menu. We're not a part of that, but that's what we've seen our white sharks are eating, are those kinds of things.
Great, thank you so much.
You're welcome. So part of that nutrition puzzle can also be confirmed using the tag technology. So let's go ahead and have Dr. Huter talk a bit about what the tagging process is like and what the tags do.
So while the guys on the contender are trying to catch us a shark, let me show you the satellite tags that we'll be putting on these white sharks. This is a spot satellite tag, goes on the fin like this. When the shark comes to the surface and the connection, the circuit, the electrical circuit between this copper circle here and this copper circle down here is broken, then the satellite wakes up, satellite tag wakes up, sends a signal to the overhead Argos satellite system, and that's what becomes the pings, the little circles that you see on the shark tracker. So watch these tags work. This is what OCEARCH is all about.
Yeah, so it is what OCEARCH is all about. Dr. Huter is absolutely right. And so let's talk a bit about the technology behind the tags and what kind of information can we get from these tags, okay? So we'll start in this picture. You'll see tag technology and telemetry. So if you go all the way to the right, you can see the spot tags. These are spot 5 tags or spot tags. They are smart position or temperature tags, and they have a battery life of about 5 years. Can any of you guess why 5 years would be important? What kind of things could we tell in 5 years? Especially, let's talk about like a female mature white shark who is able to go through mating and the reproduction process.
Mrs. Martinez, do you have anyone that would like to take a stab at that question?
So why 5 years? Jans?
Because like let's say like 5 years last fall and you want to make sure that you are prepared and everything.
Okay.
So that you do not like say like if you like if it lasts like a few months then you try to find
Okay. I don't know if you can hear his answer. 5 years, and you're saying that the point is that it's a female shark that we're talking about?
Yes.
Yeah.
So, and did we listen to how often they give birth?
1 or 2 years.
Every couple of years. So we have an idea. Oh, good, you're nodding. We have an idea that it's about that.
That's
Excellent.
exactly
Thank you
right.
so much.
That's great. Yes, that's what it's all. So when we started the North Atlantic White Shark Project, OCEARCH was able to tag a mature female, Mary Lee, who by putting that tag on her fin, we started that piece of the puzzle to be able to see get some clues about where the mating site might be and where the birthing site might be. And so that 5 years should have been able to give us 2 full cycles of that process by following her tracks. We reached her 5th year this year. So unfortunately, I don't think we're going to be able to see any more of Mary Lee's pings coming in, which is kind of sad, but we were able to gather the data that we needed from her, which is wonderful. But that's exactly right. That's why 5 years it would be important.
So
that's
Lindsay,
tags. Go ahead.
since we're talking about reproduction, we have a question. What age do the female great whites, when do they stop being reproductive? Do we know that yet? Or is that something that we're still trying to figure out in the puzzle?
That's something that I actually don't know. And I think that's probably something we're still trying to figure out. That's a really great question. And you know what? I'm going to write that down and I will go ahead and ask that for you. Or you're also welcome to tweet at OCEARCH on Twitter, and they would be happy to answer your questions. They'll either answer it directly or they can have one of their scientists get back to you, because a lot of our scientists are active on social media.
Great, thank you.
You're welcome, sure. So you have those spot tags that are going to give us 5 years of data. And then actually these next 2, next to the spot tags, are also satellite tags. So these tags, satellite tags, are going to be talking, just like Dr. Huter said, to the Argos satellite system. And those are the pings that you're seeing on the OCEARCH Global Shark Tracker, which I'll show you how to use in a little bit. And then on the left side, all the way to the left, you'll see some acoustic tags. And that's another something that we put on the shark. So we'll roll the shark onto its side very carefully. And then the white sharks have a little abdominal cavity, a little space in their tummies where you can take an internal acoustic tag and insert it there. And that tag will be able to give us data for 10 years, which is wonderful. Now, what's interesting is how the acoustic tags work is that shark, whenever it swims by a receiver buoy, that tag will emit a sound, and then that sound is picked up by the receiver and it's recorded on a computer. And so then the scientist is able to go out from from shore, come out to the receiver buoy, download the data when they're able to, and then go back and take it to the lab and see which sharks have been through that area. That's great because, like I said, we'll have then 10 years. So long past when Mary Lee, we're not able to get her spot tag information, we're still going to be able to get her acoustic tag information, which is great. We've also been able to use that with sharks who have had biofouling on tags, which we'll talk about in a bit. If something interferes with that tag talking to the satellite, we can use that acoustic data to still gather some ecology studies that we're doing. So that's really wonderful. And so that's what these tags are. If we can go to the next slide, you'll see the last of the 3 tags. So see, we have that spot tag all the way to the right. This spot tag is much smaller though. That's going to go on like a young of the year or juvenile white shark. And what's neat is it also, you can't tell maybe in that picture, but it has a design that's a little more hydrodynamic. So there isn't a lot of pull against the tag when the young of the year is swimming with it on it. But you can also see right through it and see the batteries inside because that one hasn't been painted yet. And then that middle tag is the acoustic tag. So there it is again. And the third tag that is going on some of our sharks is a PSAT tag, or a pop-up satellite archival tag. What's really cool about this is this tag is able to gather information like the salinity of the water, the dive profiles of our white sharks. You can tell the temperature of the water around them. It's really interesting. And that tag then is designed to pop up, to detach, pop off, come up, pop up to the surface and start transmitting, and can talk to a satellite and give us positional data on where it is. And then the researcher is able to go out and either retrieve it, or we've also had some of these wash up on shore and people have been able to send them back to us when they found them on the beach. But it's going to give that layered data, if you will, about not only where the shark is swimming, but how they're swimming and what the environment is like around it. So those are the 3 main tags that we use. Now, you might notice that this tag is clear, like I said, right? This tag is clear, but on the previous slide, they have different colors. Why do you think that is? Does either class have a guess on why that would be?
Mrs. Troopers, you guys want to take a guess?
See, that one has different color. They're both spot tags, but they're different colors. And then the other one you can see through. Why wouldn't all of them be see-through?
Possibly different genders or shark species.
Ooh, that's a good thought. Very good thought. Any other guesses?
Maybe their age.
Age.
Maybe
So we will fit the shark based on its size with the right size spot tag. See, like we said, the juvenile will get the smaller spot tag, and then the larger tag will go on a mature or even some of our immature, like a Savannah that we tagged, a teenage white shark that we tagged. And the reason there's a difference is because the other 2 spot tags, the larger spot tags, are painted with an anti-biofouling paint. So what can happen is when these sharks are in the water, you know, you have 5 years with that spot tag, then we have organisms that can start to grow onto the tag. And when that starts to build up on that antenna, it makes it so the antenna isn't able to communicate with the satellite, with the Argos system. And so when that happens, we can see things on the tracker like a Z-ping. You might see this shark has pinged in, but we can't gather location data. We call that a Z-ping. And that can happen where it's saying, I'm trying to tell you that I'm here, but I'm having trouble talking to the satellite. Or you may not hear from a shark for a period of time because it's totally interfered with that connection because of biofouling. So that is something that our scientists and researchers and OCEARCH and wildlife computers are working on together, is being able to develop a way for those tags to maximize that battery life and maximize that data that we can get from that shark and keep it from biofouling. So we have a lesson plan about our tags that you can download for free. And you can learn about the different tags and what they record and how they're used. And maybe you can help us be part of the solution and help us figure out a great way to keep those tags from biofouling in the future. Another thing I like to have students look at too is what kind of technologies would you like to see on a tag? I've had several students talk to me about, hey, why don't we have a camera on those tags? And then think about the challenges of a saltwater environment. Think about the challenges of the battery life on the tag, adding something to the tag that's already being used for location data. How would that work with also needing to use energy for a camera and things like that? But I would love to hear from you all and hear what your tag design ideas are for our sharks in the future.
All right, Lindsay, I hate to butt in. We have about 5 minutes left. So I know you wanted to talk about the shark tracker. We do have some questions about that. So if you just want to do a real quick overview, and then we'll take some final questions, okay?
Sure, sounds great. So I mentioned before that, so when we started the North Atlantic White Shark Project around 2013, we didn't have any data on where our white sharks were in the North Atlantic and where they were going in the mating and birthing site. So can you see the tracker now?
Yes, we can.
Wonderful. So this is the OCEARCH Global Shark Tracker. This is the desktop site for it, where you can track our sharks in real time. So when we started, you can see where Mary Lee went. She is a mature female white shark. Here she is, Mary Lee. We type in her name. Now, see, look, you can look at our most recent activity. You can look at species, at genders. You can really sort what you want to look at here on the tracker. But all I have to do is track shark. And there she is. That's where Mary Lee last pinged in. I touch her ping there by clicking on it. And you can see where that's her. And then I can look at her track. And this is what she showed us. It's been very interesting to see how these mature female white sharks are using the North Atlantic. So you see that she's offshore a lot of times. And so she started in Cape Cod and came down. Look how much she uses low country area of the United States. That's something that we're researching right now, is how white sharks are using this area. And then she went up here into the New York Bight area during the months of June and July, when we think is pupping season for white sharks. And that's what led us to Expedition Montauk, where we were able to take that information and talk to local scientists with the Long Island Shark Collaboration. And they confirmed they were seeing some very small white sharks during pupping season time frame. And they went and did 2 expeditions to find the young of the year white sharks and the white shark nursery in the North Atlantic. And we were over 2 years able to tag 20 young of the year white sharks and complete that study last year, which is great, and see where our young of the years are headed. And I can show you that right now. So we have all of our sharks are named, which is so much fun. But I'm going to show you Bruin, the young of the year, because Bruin is named after a school. There we go. There's Bruin, and then I scroll down, track shark. And this is what we're seeing for the tracks of the young of the years. This is about their range from that New York Bight area, see all like over to Rhode Island and then down over to North Carolina. And that seems to be about their range within that first year and up to 2 years of life. You can even layer this data. Look at this. Let me put another young of the year in here. There's Mission. Go down. Track shark. And see, now you can see both sharks because they're in 2 different colors. So now you've seen where the mature white sharks were showing us for females, where the young of the years were found helping using the knowledge from the Long Island Shark Collaboration and the pings from Mary Lee. And then we need another piece of that puzzle, which is the mature male white shark, which our mature males are Hilton and George. I'll go ahead and put George.
Lindsay, while you're typing them in, we do have a question about, is there a difference between great white sharks and Atlantic white sharks?
I am not familiar with the term Atlantic white sharks. I can tell you that white sharks and great white sharks are the same species. So Cacardon cacarius.
Okay. And back to the tags while you're showing us the tracking.
Sure.
We had a really interesting question from Jason, and he wants to know, does the anti-biofouling paint ever chip off? And do fish ever consume it? Is it harmful to any other organisms that might take a pick at it while the shark is swimming around?
So I don't honestly know a lot about the anti-biofouling paint itself. I don't believe that it chips off. I haven't heard about that happening with our sharks, which is great. You really want it to stay on that tag, like you said, but we wouldn't use anything that would harm the environment or harm the sharks. So I'm sure it's gone through numerous tests to make sure that they're safe.
Great. All right, you ready to move on to your next slide?
Sure. So yeah, so here's Hilton, and this is where our mature sharks are. So see where some of this is overlaying with our mature females. And that's that last piece of the puzzle. We've found mature females, we've found immature sharks, we've found young of the years, and now the piece of the puzzle that we're currently working on is that reproduction and that mating site, which is really exciting. Okay, stop sharing. Okay.
You ready for the video on the next expedition?
So what we're working on right now, OCEARCH is on expedition right now. They're 30-second expedition, and you can go ahead and take a look at how we're looking at how this Atlantic white shark puzzle is fitting into the bigger piece of the health of the North Atlantic Ocean. So this is Expedition Gulf Stream that we're on right now. The OCEARCH is drifting the Gulf Stream, and they're doing all kinds of great research projects like looking at lionfish studies, sea turtles. How are whales or cetaceans using the Gulf Stream? There's some questions about how whales are using the Gulf Stream in the North Atlantic, and doing sargassum studies and looking at the health of the entire ocean. And so that we will see how our white sharks are part of that bigger piece, that bigger puzzle. And actually, come to think of it, you need to know that you are a piece of this puzzle too. Really, you are. You are the future stewards of the ocean. And the future of the ocean is in your hands. So there are some things that you can be doing to help us help the ocean and help sharks. And some of those things that you can do is you can help make sure that you're reading labels of things that you're buying, see what's in them, make sure they're from sustainable sources. And you can be a part of the conversation and help educate others. Participate in beach cleanups and neighborhood cleanups. Even if you don't live next to the ocean, you can clean up. There are many waterways that end up going to the ocean. And then that last piece is about plastics. The plastics are a piece of the ocean puzzle that we are looking at to see how our plastics are affecting the ocean, how it's affecting sharks. And so by reducing our single-use plastics, that is a big help to everybody. And actually, I think, Jacqueline, you can tell us a little bit more about that and what EarthEcho is doing and the exciting things that you'll be doing with Plastic Seas, please.
Yeah, so this year is very exciting for EarthEcho. We will be traveling to Melbourne, Australia in October. We will be picking 25 exceptional middle school teachers to go with us and look at plastics in the ocean and help us decide and create STEM design challenges that will get youth, like everybody watching today, interested in what solutions can we do, what can we do now to help our planet and to save our ocean and to get that plastic out of the ocean and to stop it from going into the ocean. So stay tuned for that. We will be broadcasting from Australia, and we'll be, documenting our journey on social media when we are there in the fall. So that's super exciting. Yes. And Lindsay, I have one more question from you that I'm curious about as well. And that is from Ben. And he wants to know, is there a difference in shark years versus human years? Kind of like there's a difference between dog years and human years?
That is a great question.
Right? I thought so too.
I've not been asked that before, and I don't know. So I don't think that there is, but that I will go ahead and I will ask, because I love that there's still so many things that I don't know and that we're finding out. So I'm going to ask if there's a difference. Thank you so much for your question.
Excellent. So as we wrap up here today, I just want to say thank you to everybody for joining us. You can see on your screen now how you can follow OCEARCH. They have all their social channels there. And I would also highly recommend that everyone download the Global Shark Tracker app. It's really fun to watch the sharks and see where they are in the world and watch their pattern. It's really, really fun. We also have our EarthEcho. We encourage you all to follow us as well and follow our adventures and our partnerships. So you can see our social channels there. If you have any questions that didn't get answered today, you can feel free to email education@earthecho.org. And we would also like to invite everybody to March for the Ocean. So on June 9th, our team will be marching for the ocean at the Capitol in DC. If you're not able to make that, that's fine, but we're asking everybody to wear blue. So if you don't know, June 8th is World Oceans Day, which is my favorite holiday as well as Lindsay's. And we love World Oceans Day. So we'll be marching for the ocean. So wear blue on June 9th and show your support for the ocean. And I believe we're going to wrap up there. So thank you, Lindsay, so much for your time and educating us about the sharks. Mrs. Trumper and Mrs. Martinez, thank you guys so much for joining us. We hope you had a good time today. Thank you. I see you waving there. And we will let you all know when our next virtual field trip will be planned. And for all of you guys that are getting out of school, I hope you have a great summer and stay safe. Make sure you track those sharks, and we will see you all again soon. Thank you so much. Have a great rest of your day. Bye, y'all.
Thank you so much.